Hello, everyone. Welcome back to Advent of Code. It's 2023 still, and yesterday I finished on camera in yesterday's video. We did part 1 of day 10, and I took a break because part 2 looked like I couldn't come up with any great algorithm for part 2, and it had been like 2 something hours. I didn't want to start on that. So, I wasn't sure whether I was going to do part 2 today, but it's been about, I don't know, like 20, almost, I think 24 hours for me since the end of that video, and I've thought about it on and off, and I think I have an algorithm that doesn't seem too difficult to implement, and I think it should work. I will confess, I did not 100% think of this algorithm myself. I was browsing the Advent of Code channel on the Discord, the functional programming Discord, and I didn't like copy the whole algorithm from there, but I saw someone mention that they were just scanning from left to right, and I was like, that I think was what I was missing from my previous I was missing that in my previous ruminations. Recall, we have this like loop. We have a closed loop of pipes, and for part 2, we're asked how many coordinates, how many locations are inside of the loop. And in this case, you can see here, like, these 4 are the only 4 that are inside the loop. And I was having all these thoughts about, well, we could flood fill from the outside, knowing that the outside rim is definitely not inside the loop, and then every time you cross over one of these pipes, you would like toggle whether you believe you're inside the thing or not. But it seemed kind of hard to do that. How do you detect when you're crossing over the thing if you're like flood filling in from the outside? So what what this comment about scanning from left to right made me realize is that if a cell is inside of the loop, then in all 4 directions, like casting out rays from this cell, say up like this, down like this, left like this, or right like this, you will cross over an odd number. You will cross over the loop an odd number of times. So it doesn't matter what direction you get to there from, as long as you can count accurately every time you cross the loop in that direction. So, for example, in this input, it's pretty easy. We would, do a bunch of scanning, and we would, okay, let's leave these for now, but on this row, we would say, oh, well, we've crossed the loop 0 times. Here, we would say, well, this is part of the loop, so we've crossed it now, but we won't include this because it's part of the loop. We get here and say, oh, we crossed the loop once, yep, include it. Crossed the loop once, include it. Now we've crossed the loop twice, so we're not going to include what we find. This one, okay, not part of the loop. Now we've crossed it 3 times. These 2 are therefore in. Now we've crossed it 4 times, so this is back out, right? So that's how we would get that row. And for these, we would cross once, twice, and then we'd be in here and say, okay, we're not going to include those, right? And the same idea applies just as well here. And it doesn't matter that there's not this path from the outside in, because we're not looking at that. The main challenge for this approach, I think, is how do you know when you have crossed the loop? It's easy when you cross one of these. You say, oh yeah, that's definitely, however many times I crossed the loop before I saw this, I've crossed it one more time after seeing this. Fine. But what about there's kind of this issue where, like, okay, you're scanning from L, right? You get here, and you're like, well, I haven't quite crossed the loop when I get to this cell. And this doesn't really affect whether you've crossed the loop. You've kind of partially crossed it. And then you get to this J, and you're like, oh, never mind. I never crossed it at all, right? You like half crossed, half crossed, half crossed, half crossed, never crossed. And so you've crossed it 0 times when you get here. How is that different from, well, here you've half crossed it, okay, crossed it once, crossed it 1.5 times, 1.5 times, now you've crossed it twice. So what's the difference between J and 7 here? And what I came up with while, thinking about this on and off through the day is that to count the number of times you have crossed the loop when traveling west to east, or in any horizontal direction, is well, so the difference between J and 7 is that 7 opens to the south while J opens to the north, which sort of sounds obvious, right? But the point is that L also opens north. So if you cross over a junction that opens north and then another junction that opens north, you haven't crossed the loop. But if you cross over a junction that opens north and a junction that opens south, these, then that's sort of a virtual vertical piece, right? That makes up an entire vertical. And you don't have to worry about what if I run into an L and then I run into another L? Well, that's not possible. You would have to run into a 7 or a J before you run into another L. Because if you see an L, you're going to see dashed lines until you see a junction, and the junction can't be L because that doesn't connect up. So what we can say then is, scanning from left to right, we count the number of north opening pipes that we see, whether they're of this strictly vertical type or of the L type or the J type. So that's the number of north-facing openings we see, and the number of south-facing openings we see separately. So that's the verticals and the Fs and the 7s. If both of those are odd, then we've crossed then we're inside the pipe. Oh, wait a minute, I'm just realizing something maybe even better than what I thought I had. If one of them is odd, then we're currently riding along the pipe itself. I think that's true, right? Yeah. And if neither of them are odd, then we're outside the pipe. Outside the area enclosed by the pipe. So that's actually kind of cool, because I thought I was going to have some special, based on the parity of the things and whether we're currently looking at the pipe, the loop, you still have to identify for each cell whether it's part of the loop in order to know, whether you should consider this at all. But you don't have to have one case for what's the parity of the things, and also are we on the pipe or not, because on the loop or not, because the parity of the two numbers you're tracking will always tell you whether or not you're currently riding along the pipe, or inside it, or outside it. It'll tell you which of those 3 cases you're in. So I think then for part 2, what we do is we first reuse some code from part 1 to get a set of all of the... So that we can mark, basically, each thing, whether it's part of the pipe. part of the loop. Then we scan over the entire space, starting at 0, 0, and going down to the maximum element. And it'll be easy to compute both of those because our map is ordered. So we can just ask what's the minimum and what's the maximum coordinate stored in the map. And we scan through each row left to right. For each row, we start the counter again at 0, 0. And then for every pipe we see that is part of the loop, we update the parities of the north and south facing pipes. And if that, for every step where those parities are both odd, we add 1 to our number, our running counter, and otherwise we don't add 1. I think that's... Yeah, it just wants to know how many tiles are enclosed. So I think that's a sketch of like the algorithm, the plan that I have in mind. Okay, so I haven't looked at the actual program in the last 24 hours. Let's see. One thing I guess to consider first is when we are scanning over the input to tag the ones that are part of the pipe. One thing we could do would be to like keep this map from coordinate to whatever and have a second set of these pipes are actually part of the loop. And then when we see a feature, we could say, oh, is it part of the loop? But I think it's easier to just... Once we've computed which pipes form the loop, to just replace every other element in the map with emptiness. What is data map? What are some things you can do to like combine lists perhaps? Difference. It's not quite what I want. Oh, difference width? Oh, that's exciting. When two equal keys are encountered, the combining... Oh, no, that's not interesting. What I want... is like... For the when I want to take the map that I have and also a set of items that are actually important, the ones in our loop, and update everything that isn't part of that set and replace it with like empty. I think empty is what I called that. So does one of these combining functions not do that? Or update, delete, adjust? I mean, these are all single edits. Filter, submap, no. Maybe I just want map with key. Where I look at the key, and if the key is in the set, then I return the value that was already there. And if the key wasn't in the set, then I return empty. I guess that's fine. And that way we can throw away the set of what's in the loop because it'll just be... Yeah, I think that makes sense. Okay. So let's take part one and pull out this ray trace here, but we need to also capture its lexical closure. What variables is it closing over? Just the grid, I think, right? Yeah. So, boy, Emacs is really slow because, like, I think my Windows subsystem for Linux system is getting like paged back in or something because I didn't use it for 24 hours. So just random operations are slow. I mean, I guess I might as well, make sure stack build is still going. And what's 1? Okay, great. Just type some stuff in there and I'll let that warm up. Ray trace of grid. All right, tell me what type this has, please. I don't know, I guess I can probably figure it out, right? Ray trace takes a m.map of core. Oh, there you go. Can Tmux copy this for me? If I paste, am I going to be happy with what I get? Yeah, it's fine. But I want to like iterate this, right? Well, no, I don't need to. This can just trace it once. And then I can again call iterate ray trace. I'll only need to trace a single ray because I don't need to know exactly what's halfway around. I'll just run one ray around until we get back to the origin. This one is actually not very good for computing the whole thing because it takes these two rays, and then when they get to the end, we like delete the element that was there so that we don't know which one was at the end. I think it's going to be better to just trace from the start to the start. Origin grid is, and we're going to have a lot to do here, but we know sort of what we're doing, right? Let's see. Is this still a good idea? Do I need to get this pipe? I think so. Because I need to choose arbitrarily one of its endpoints. Yeah. Let's write a let in there. And then choose one endpoint arbitrarily, or one direction arbitrarily. Loop coords is origin cons to it's s dot from list of, do I have s in scope? I don't. It's origin cons to, well, I can probably write this as a list comprehension, right? Or as a function composition. Take while not equal origin, tail, iterate ray trace of ray trace of grid, all applied to what does ray trace take? I've already forgotten. A direction and a coordinate. Well, we have a direction and a coordinate, right? So apply that to the direction being I and the coordinate being origin, right? let's just real quick say lexical error at character new line. What have I done? That never happens. What? Here? Oh, there's a quote there. Okay, great. So we have a type error on line 76 here. Sure, yeah, that makes sense. Map ray trace of grid, please. Yeah, Tolly really should have been tail, it turns out. Okay, anything else? Yeah, that's true. We are getting back a list of coordinates and directions. So I guess I want to map. What order does ray trace give them back, Ken? I want the second, okay. Okay, but that actually is in the wrong place. It should go before I call take while not equal origin. It should go like that. Yes. So that, I hope, computes the size of the grid. Now, what was part 1 asking us for again? Like the maximum distance? Yeah, how many steps does it take to get from the start to the furthest position? So our answer for part 2 should be exactly double the answer of part 1 if this is correct. If the part 2 implementation is correct, right? Obviously, this isn't the final part 2. I just want to test what I have so far, and I think well, no. Well, yeah, right? Because if you draw the absolute simplest possible grid, which is this, then it takes 2 steps to get from one corner to the other, and the grid overall, or the loop overall, has length, perimeter, I guess you could say, of 4. So yeah, and if we like did this, then it takes 3 to get to the corner, but total size of 6. So I believe we should get a delta, a ratio of 2 here. Yes, that's exactly twice as large. So I'm reasonably happy that this part of the part 2 implementation is correct. You know, I guess I could have just reused this for part 1 and then halved the result. Couldn't, or yeah, that didn't occur to me. Because I was like, oh, I want to find the point at the end. That's going to need 2 pointers to like run into each other at the end. But if you think about it, the furthest point on the set is always half the distance away. So I could have just found everything and then halved it. That's interesting. Maybe let's do that then, just to clean things up a bit. Loop. Perimeter? I don't know. Because perimeter is often used to mean, like, what is the distance? Like, how long is the perimeter? We give it units of, like, length. But it also, like, the perimeter is the actual line. We just usually talk about its length. So I think it's fine to have this function named perimeter. Perimeter takes a coordinate and and a grid, right? Why doesn't it just take an input though? Set of coord, right? And then we can say, like, it's literally this function. And we just return loop coords. Now, we're going to, in a minute, reintroduce the binding here, but of the origin and grid, because we're going to need them for the rest of part 2. But part 1 literally can just be this, right? Part 1 is div 2 composed with s size, composed with perimeter, right? Yeah. Still 7005. Great. So we didn't need that, like, not all same thing. And now, for some reason, it feels better to use a where than a let in. I don't have a good reason for that, but where? I don't know. Let's try it. Where loop coords is this. Oops. The only place I'm using P is here, right? But I kind of do need the pattern match because it's doing. I can't just inline it very easily. So I need to turn the feature that this lookup gives me into just a pipe. Okay. And I don't know. I mean, for both let and where, the order of the bindings doesn't matter. Laziness ties them all together, and GHC solves the dependencies just to get them for you in the right order. But it just feels more natural with wheres to write, like, it's loop coordinates, where loop coordinates is this thing, and if you need more details about loop coordinates, look here. And if you need more details about where I comes from or whatever, or where P comes from, look here. Whereas for let, I don't know. I write it in the other direction, where I say do something, then use that thing, then use that thing. I don't know. So let's git add this. Yes. And I want to split this a bit. Well, no, I kind of want to edit this hunk. So I don't want to include the change to part 2 in this commit. Come on, hurry it up, chop chop. Okay, so here's the diff that we want to commit, but I can just remove this, basically. That should work, right? Patch does not apply. Ugh. Yes, and so why do I do this to myself? I don't know. But why doesn't it apply? Well, okay. I mean, so like, I can just make this part of the context, I guess, right? If I put it here. That should apply. There we go. Git commit -m day 10. Refactor to use or determine perimeter? Sure. Yes. So we can now look, get this is, I don't know, like, oh, did I make a mistake here? What's going on? I guess I accidentally committed a white space change to part 1. Yeah, I put part 1. Okay. So if I edit this hunk, what exactly edit do I want to make? Yeah, I want that. Right? Take away the white space that's in between these two and put it after part 1. That's better. Cool. So that's, I don't know, like, this is unnecessarily fancy stuff to be doing with Git. But I like the, I don't know, the separation between the index, your actual commit tree, and your working tree. And the freedom that it allows you to do some work. They call this, like, the tangled working copy problem. This is what, okay, I don't actually have a tangled working copy at the moment. I sort of do. Right, you made a bunch of changes to the file because you were working on something, and now you want to commit, but you want your commits to reflect, like, not the exact insane order you did things in, because let's face it, developers are insane. You want it to reflect a meaningful history of the project. Obviously, for a tiny project like this, that nobody is ever going to check out besides me, it doesn't really matter, right? You could be sloppy. But I kind of, just like with admin of code, I like being tidy here and crafting good Git commit histories. I don't want to say, like, oh, you know, part 10 just did a bunch of shit. Like, I want meaningful chunks of changes to be my commit history. And so the tangled working copy problem is, like, you've made a bunch of changes and now you want to commit stuff, but, like, you fixed 5 different bugs in one day and you're like, whoops, I should commit those. And as long as they don't, like, overlap in lines, you can use Git. You can, like, split and say, oh, I'll commit this chunk of the edit as one commit. I'll commit this chunk of the edit as another commit. Git add-p helps you select those. And you can even do minor surgery, as I did here, when, like, it's not perfectly split up by line. Although here I feel like it should have been. It was just, yeah, it was. But when you ask Git add-p to split a hunk, it splits it by, like, if there are unedited lines in between, then it considers them to be different chunks. And in this case, there were no unedited lines between part 1 and part 2, but why not? Am I crazy? Shouldn't there have been an unedited line, a blank line between them? There is. Huh. Okay, I'm not totally sure why I needed to do that anyway, but okay, fine, it's done. So now we can say part 2 of input origin. I don't even need the origin, honestly. Grid is. Let's do some letting. Let loop equal perimeter of input. And I think we want to compute grid prime, which is the grid with everything that is not part of the loop replaced with an empty space. I think that's pretty easy to do. Loop prime is m.map with key of only loop over the grid, and let only loop of, it's a function taking key and then a what's there, I think, k and then x, where s member k loop prime, no, loop equal, oh, we're not calling this, we're calling it grid prime, of course, not loop prime. If k is a member of the perimeter, then we should return x. Otherwise, we should return empty. And so now we've cleaned up the grid by removing, replacing all coordinates that are not part of the grid, of the loop, with just empty space. And I think now, let's see. We know that the top left corner of the grid is 0, 0 by definition of our coordinate systems. We don't have to ask the map what its lowest element is. But we do want to know its largest element. So what is, in data map, query? We want like find min, find max, or something like that. I don't need any maps or traversals or whatever. Okay, I guess I should have scrolled a lot lower to start with. I guess I just control F for max, huh? Fine, max. Min, max, here it is. Okay, so look up min, look up max. Find min, find max, they call an error. They just fail if the map's empty. Okay, and so that's all I need, right? God, I love functions like maxView. They're so I'm not using it today, but it just reflects the functional perspective on things that, like, in an imperative mutable language, you'd say, all right, you know, this reflects a pattern matching oriented view of the world, right? You would say, okay, I'm going to get the max of the list, and then I'll delete the max, and then I'll do, or like, right? But here, there is no mutable delete, so it's kind of nice when you're calling a map with the plan to, like, you want a map with that element removed and you also want that element. This gives you both things. It says, oh, here you go. Here's the item you were looking for and the map without that item. Just nice, right? Anyway, we want find max, I think. Yes. Chord of max y max x and ignore the value equal m dot max find max of grid prime. We could look in the grid as well, but might as well use the grid prime we just built. Oh, a digression. There was something I thought about earlier today that a way we maybe could have changed part one, and I don't know, or not part one, our input parsing, which is this horrible function we said we'd never look at yet again. It wouldn't be a huge change, but remember, we parsed the input list into a map of features, and also once we had that parsed, we iterated over it again to figure out where is the starting point, and then look in the original list to say what's above, below, left, and right of the start. But I think if we had used a lazy map, we could have done both of those steps at the same time. We could have said, okay, the value of the finished map at any coordinate is just like, if that coordinate is the start, then look in the finished map in every other direction. Otherwise, just it's whatever the value should be. I think we could have avoided the initial grid step here. Where is... Oh, where? I know there's... this map accum with key. I think this maybe could have been avoided and done in the whole computation of initial grid could have done this as well. But I'm not going to do that today. It's fine. I just had a thought that oh yeah, maybe there was a reason to use a lazy map yesterday, even though I said I couldn't think of one. Which was that we didn't know what pipe should go at the start until we parsed the whole map. But laziness would let us do those in kind of interleaved order. So, part 2. Still working on that now. I found the max y. I found the max x. I honestly feel like it might be time to write in some map enclosed of 0. Oh, why do I need max x? I mean, I kind of don't. Okay. Putting this underscore here just to tell Haskell I'm intentionally not using this, but I do want a reminder that it represents the max x. Max y, right? And then enclosed is just the function that's going to work on a row. Where enclosed... Oh! See, now this whole, grid thing is not in scope and enclosed anymore. So this is it's hard to mix let and where sometimes. We could either turn this whole let in into a where, which honestly makes sense to me. I don't know why I start with lets and then change it to wheres. Like, why don't I just start with where and admit to myself that's the way I like to read it, but let is the way I like to write it? I don't know. Well, like, this is actually a really nice, like, definition. It's the sum of the enclosed values from 0 up to max y. If you want to know what enclosed and max y are, read on, right? Where right? And then we can say, let's see, what order do I want to write these in? I guess that one first. Well, I'm not even using this except in enclosed, right? So the other thing we could have done, instead of turning from where to in, is to pass, like, to write instead enclosed grid prime. And then where could use that, right? Actually, maybe that's a nice way to do it now that I look at it. All right. Hit undo 1,000 times. Turn this back to let in for me. Because our definition of enclosed is not going to use this value. It's not going to use this. It's not going to use loop. Like, it's not going to use anything except grid and the row it's supposed, the x value it's supposed, the y value it's supposed to look at, right? And so I think having that be a top level function to kind of, well, actually, it doesn't even have to be top level. It could be local. But the point is that now enclosed explicitly doesn't have any of this stuff in scope. So you can read the definition of enclosed in isolation of the rest of part 2. And knowing you're not missing something. Although I guess it does have input and grid in scope. Let's just make it a top level function. Enclosed takes an m.map from chord to feature and an int and returns an int. Enclosed of grid row is go of 0, probably? Well, no, shouldn't we be able to fold something over the row? This is a fold. It doesn't have to be a manual recursion. Oh, although we don't have, like, a slice of the grid, do we? You know what? Let's use this max x. Oops, that doesn't go here. It goes, I'm going to pass 2 ints now. There you go. So now I could fold over the items in the grid, kind of, right? Yeah, I'm trying to, like, as I fold, what do I want to keep track of? I guess I want to keep track of a 3-tuple, which is parity, whether parity of north, parity of south, and total that were inside. Yeah. Okay. So let's write. But the sum is like what we actually want out. So I think this is actually like a map_QML kind of situation. What does that function do exactly? Let's look that up. Not max_QML, but map_QML, please. In data list. It's a combination of fmap and fold_L. It applies a function to each element, passing an accumulating parameter from left to right. No, this is not what I want at all. I want... Do I want a scan? Oh. Maybe a scan_L makes sense. Because then I only have to scan the two tuples that I'm seeing, right? And I can do a post-processing step on that to say, okay, great. Here were the two tuples as I went across the list. How many of them were odd, and then just take the length of that list. Yeah, that's nice. So length filter both even, I guess. Let's look at the endpoints function for a pipe. What exactly does this tell me? Yeah, I mean... I guess that's fine. I'll just... Okay. Filter both odd. Scan_L update. No, let's call it parity. Scan_L parity of 0, 0. Composed also with map m.lookup in grid on the you know what? On the row, where row is map m.lookup grid on yx, where y is drawn from 0. No. Y is fixed, where x is drawn from 0 to max x. Oh, and why am I writing a map here? I should just... do that, right? Length usually is spelled with an E. Yes, you're correct. Both odd of norths and souths is odd. Odd exists, right? Yes, there it is. Odd norths and odd souths. Boy, you could really make this function definition more complicated if you wanted, couldn't you? You could write both odds is uncurry of and on odd? Oh, it's so bad. Right? I mean, that definition works, I think. It's actually not. Maybe it kind of is nice. You know what? It's my party. I'll have fun if I want to. What? Oh, they're both infix are 0, huh? Or they're both infix 0. Okay, well, fine. I'll use parentheses if you're going to be a bitch about it. Yeah, so let's just have... let's just... oh, I can't write. You have to do something different to copy across tmux panes. So I want from here to here in pane 2, please. I just want to demonstrate like what that this does work. Both odd of 5, 7. Oh, define it. It says true. Both odd of 5, 6. Nope. If none of them are odd, 4, 6, it still says nope. So we might as well for. I like this definition. It's kind of fun, and I don't think it's unreadable. Like, even if you don't quite understand how it all works, the name both odd, and you see like, oh, we're calling and we're like calling odd, you know? The punctuation of on and uncurry is sort of like, you can ignore it if you want. But so uncurry takes a function of 2 arguments and returns a function that takes a tuple and just calls the 2-argument function on the elements of that tuple. So that's the way we're unpacking the parity. And on takes a function of 2 arguments and a function of 1 argument. And it calls odd on both of its arguments and then passes the results of both of those calls to and. Just kind of fun. So we need what? Parity of now, wait a minute. Why is it telling me parity that's the type that parity should have? Can't it infer something more specific? The problem, I guess, is that my other function types are no good. I got the argument order to mbang wrong again. Yes, this is better. Now it says, parity is a function from a 2-tuple of some kind and a feature to a 2-tuple of some kind, right? And I imagine it'll be more specific and say, oh, the b's have to be integral, right? No? Wait. What? Okay, I still have something wrong with... okay. This type... coord... We're not using tuples, right? Coord takes y and x in that order. Why can't it figure out that parity... should be returning integral types? We're calling both odd on the results, right? Interesting. Oh, because I'm wrong. No. Parity takes two numbers, right? Weird. I don't know why it can't tell, or why it doesn't say in the error message that B0 has to be integral, or at least numeric. But okay, it does anyway. So parity, what if I just for fun said parity is function from A to A and a feature function from A to A. Parity is undefined. Won't you complain here and say it has... No, of course. You'd be perfectly happy if parity had a more general type, wouldn't you? Yeah. That's the issue is... Parity doesn't have to be constrained to work on numbers. Maybe parity works on anything, and I just happen to apply it to numbers. Okay, very funny. Parity of norths, souths, and an empty? No. And a pipe of P is, we'll leave that undefined. Parity of P and anything is just P. So if we see something that isn't a pipe, we'll leave the parity alone. If we see something that is a pipe, then we have some thinking to do. Well, I kind of wish I were working with bools instead of ints, honestly. And I could be. You know what? Let's do that. Norths. What is XOR? I mean, I guess there's not equal, right? But surely Haskell includes something called XOR as well. XOR works on data bits. I don't want XOR for ints. I want XOR for bools. And that doesn't actually seem to exist. So I'll just use not, or not equal, which is the same thing. Not equal. Has north. South's not equal has south. Where has of D is A equal D or B equal D, and AB is N points of P. And we don't want zeros anymore, we want falses. We don't need data function on anymore, so sad. Well, you guys got a little lesson about it at least. So this now type checks. Can I I only have this one warning. Maybe I should just get rid of it. It would be nice to be warning clean, right? Line 77 here. I don't think shadowing is an issue there, right? Error. Surprised by show X. Now you're gonna warn me about the shadowing. Fine. let's just add that change now. Day 10, fix warnings. Also, how do I get... here's a question. I'm not really very good at managing projects, right? If I wanted to look at my Cabal file and say, like, please turn on... Oh, it does. Great. I did this at some point in the past, or the defaults did or something, but... I do have warn all warnings on, so great. I thought I was compiling like a sloppy person, and just sometimes I was getting errors or warnings that happened to be on by default, but great. I opted into all of them. All right, I'm a good person again. So now, believe it or not, part 2 compiles. Is it right? Maybe. Probably not, but... I guess I'll run it and see. Okay. I mean, plausible, I guess. Let's see if that's any good. Too high. Yeah, okay, fair enough. Well, I don't really have any idea how to debug this. I haven't thought very hard. I can come up with some ideas, but at the moment, nothing leaps to mind. Hang on. I think I'm including the loop perimeter itself in the parity, in the enclosed area when I shouldn't be. Right? I do actually need to know, like, yeah, I kind of need to know more than just what the parity is as I cross over. I need to know when it transitions from being high to low, or true to false, or whatever you want to say. So, because if you imagine a grid like this, when I look at this row, I'm going to say, okay, starting from the left, our parity is false, false, because we haven't crossed over anything. Great. Then we cross over the first thing, and we're sort of like, I wish my cursor type were the little vertical bar rather than the underscore. But okay. Right now, we're in between these two elements. Now, the parity of both is true. And so I should return 1. But of course, there's no elements in here, right? We have to only include empties which have this property, right? Empty cells we encounter while this parity is high. So maybe it's not, I mean, obviously just the scanl that I've written is not correct. Is there a scanl that like does something a little bit cooler? Like MapQML. That might be what I need. This is what I started with, and I said, wait, that's not what I need at all. But now I'm like, maybe it is. We start on the left. We're accumulating a parity. And we're mapping a function that produces an integer, where that integer is 0 if we're not looking at an empty cell, or if the parities as we enter that cell are not both true. And it's 1 if we're looking at an empty cell and the parities are both true, and otherwise it's 0. Maybe that does make sense. Maybe I wanted MapQML to begin with. So I think I still want both odd and parity. That's fine. But I have to do more here. Is MapQML? It is in base. Okay. So instead of filter both odd, scanl parity, I can say map sum MapQML returns the state in the left side of the tuple and the mapped element in the right side. So I want map second map accum.l. What do I want to call this function that I'm map accumulating? Update? I don't know. Go? Call it go. Why not? And MapAccumL takes S, the state, first. So I want false, false. And then it takes the list of elements to map, which is the row. So I think now I want go of P for parity, then a no, I want P for pipe as well. F for feature. Par for parity. There you go. Is the tuple parity prime and included, I guess, where par prime equals something from the parity function, I guess. I guess I should just pattern match on parity here. I was thinking that I would, in some cases, not need it, but I think I just like always want it, right? Norths, souths is par prime, which we don't have a par, but we'll define par prime anyway. Case. I just want to write case F of? I guess. Harp. Case f of. Sure, why not? If it's a pipe P, then we definitely will not be updating our... We'll be returning 0, so it'll be like something 0. Because we know it can't be enclosed by the pipe, the loop, if it's a pipe, part of the loop. And then it's... We have to update the parity, right? It's this. And we have this where clause in here that's only needed for the pipe case. Right? Makes sense to me. And if it's anything else, then I guess we can write underscore, I don't care what it is. Then it's the original parity and why did I decide this return 1 or 0? We'll just return a list of bools, I guess. Both odd par. Right? I don't need this parity anymore. MapQML is in base, but it's in data list, I guess? Okay. Import data list MapQML, please. Oh yeah, this should say false, of course. Okay. Well, give me a full screen error report, please. Computer on screen. You don't like MapQML go of false false. Oh, it shouldn't be map second, it should just be second here. Yes. So we're back to compiling. It will definitely give us a number when it runs, because we haven't introduced any new partial functions, I think. I don't know if it'll be a good number, but let's find out. Oh, much lower. Good. Well, I mean, the fact that it's lower, at least, is good. I don't know how low it was supposed to be. That low. Hey, I did it. Okay. Made it through part 10 without quitting and giving up. Congratulations to me. A bit of a long one. And an algorithmic puzzle that was, you know, enjoyable, I guess. And hopefully some instructive moments, right? And close. This is the main thing we wrote today. Took an hour to write these 10 lines. Yeah, these lines were included, but they weren't nearly as interesting. Most of the time, of course, was thinking about and describing how the algorithm was going to work. Actually writing, where is it? Enclosed was some of the time, but not a huge amount of it. Okay, cool. Well, let's commit this. Git commit Day 10, part 2. We did it. Hope you guys enjoyed. Thanks for watching, and I'll see you next time.